9.5 is called polar coordinates, so it's another alternative way to do functions. So you have parametrics and now you have polar coordinates. I think you'll find in a lot of ways it's a good way to demonstrate the world around us and kind of how we already think, maybe more intuitive than how functions go. So I'll start you off with this question. How do you identify where an object is in the real world? So think about if someone asks for directions, what do you tell them? Well, you probably give them two key things. You tell them it's over there, give them a direction, and you tell them how far to go. And that's all polar coordinates are. You tell somebody which direction to go in, using the unit circle, and you tell them how far to go. All right? Now, a distance from where you are, talk about a circle, that'd be a radius. So everything comes down to a radius and an angle direction. That's what it's all about with polar coordinates. So to put it more official, when you see a point in polar coordinates, the first number tells you the radius, the second number tells you the angle. So it's the distance from you and the direction you need to go in to get to that point. So here I've got three different points that are in polar coordinates, and this is a polar graph. It looks really similar to the unit circle, except it has lots of different radii. So instead, a unit circle would just be a radius of 1 with all the different angles that we could have. This has a radius of 2, 3, 4, 5, and 6, and this could go on as far as you want to go. One other thing to look at on this grid, and this is just one I pulled up, there's 9 degrees, there's 45 degrees. Every 45 degrees is broken up into 3 sections. So these are actually 15 degrees each, or pi over 12 if you're counting in radians. Your coordinates typically come to you in a radius, this is a distance, and then an angle measure that's in radian mode. So you do want to be thinking in radians when you do your circle. So let's try a point. 2 pi over 2. So first up it's 2, so it's on the circle with the radius of 2. It's somewhere on this circle right here. And the angle is pi over 2. Well, we know that's right there. Sometimes it almost makes more sense to start with the angle and then go to the radius. It really doesn't matter how you want to think about it. I find most students and myself, we usually think about the angle first, then move in the radius direction. So that's actually the way I'll approach it from here on. So this one's negative 5 pi over 6. Okay, so pi over 6, that would be the second line right here, or this way. It's negative, so I do want to go clockwise. And this would be 1, 2, 3, 4, 5, negative 5 pi over 6 right here. An alternative to that is if you wanted to, I don't know if it's any easier, think about where that would be in the positive direction. 2 pi would be 12 pi over 6. And if you subtract that from positive, or from 2 pi, you get 7 pi over 6, put you here. That just gives you a way to think about it as a positive angle. Sometimes that's easier. I don't know. I think it's probably just as easy to think in terms of going back negative. So negative 5 pi over 6 is this line right here. And we're at a radius of 5, so 1, 2, 3, 4, 5 right here. I'm try to color coordinate these as I go. Finally, we got negative 3, 4 pi over 3. Right, this time I'm giving you a negative radius, but I'm going to begin with the angle first. So 4 pi over 3, all right, well that puts me down here. This one, yeah, this one. Puts me on this line right here. And we're at a radius of negative 3. So here's how you handle that. You're on this line, but instead of going 1, 2, 3, you go backwards. So negative 1, 2, 3. It's actually the same thing as being a pi over 3 angle. So that's how you would deal with a negative radius. It's just the same thing as having the opposite angle, 180 degrees the other direction, or pi in the other direction. All right, so let's talk about how we convert from a polar coordinate back to our normal rectangular XY grid. So we've got 2 pi over 2. Let's just start with how that would look in polar coordinates. Angle of pi over 2 and a radius of 2. So if you're thinking about circles, put you right there. That one's pretty easy to just look at and tell. On a normal coordinate plane, that would be 0, 2. So I'm not going to spend a lot of time really worrying about that one. I'm just going to answer it and say, there you go, good enough. We'll get into kind of the details as we go along. First, I just want you to think about how to make a conversion any means possible. And that one's pretty easy there's no need to make it any worse. All right, and these are all the points we just did. So we're talking about how to convert those back. And we know negative 5 pi over 6 is down here. So something like that. All right, well, it's going to have some x and y coordinate. And that's the whole point here. So it's starting to shape up to be like a triangle in a unit circle, except it's a radius of 5 instead of just a radius of 1. And the reference angle right here, we know we like to use these reference angles. Well, that one's going to be pi over 6. Or if you'd like, you can use negative 5 pi over 6 or 7 pi over 6. I like to just use the reference angle. And remember, my y needs to be negative, and my x needs to be negative, just looking at where the coordinate is. It's in the third quadrant. So that's the way I like to approach it. So let's just think about the trig here. Now, if we want to find the x coordinate, we're going to do cosine pi over 6 would equal the adjacent side over 5. And pretty similar to that, if we want to find y, sine of pi over 6 would be the opposite side, which is y, over the radius of 5. We know cosine of pi over 6 is the square root of 3 over 2. So to wrap that one up, 5 square root of 3 over 2 is our x coordinate. We know sine of 1/2, oh, this should be negative because we're going back that way. Sine of pi over 6 is 1/2. And solving that for y is going to be 5/2. The same deal, it's going down, so that also needs to be negative. So your coordinate for that one would be negative 5 square root of 3 over 2 and negative 5/2. For the other point, negative 3, 4 pi over 3, we know that's really at the same angle as pi over 3 with a radius of positive 3. So if we set up another triangle, we've got an xy coordinate we're looking for. So we could do all that other work if you need to. I'm just going to try to kind of make it short here. We know we're going to take the cosine, to get the x coordinate, we're going to take cosine of pi over 3, which is 1/2. It's going to be pretty much the same ratios you've already done. That's why I don't really want to write it all out. So cosine of pi over 3 would be 1/2. And that would be equal to x over 3, so multiply by 3, so 3/2. And to get your y coordinate, well, the sine of pi over 3 is square root of 3 over 2. And that would equal y over 3, so multiply by 3, 3 square root of 3 over 2. There's your x and y coordinates for that point. All right, so now that you've done a few of these, let's see if we can do a generalization that gives you a method that'll always convert any polar coordinate back to an xy coordinate. So just make it clear, I want to go from that to an xy coordinate. Well, the method that's always happening, because we're making a triangle basically with some xy coordinate given this radius. So the way we get our x coordinate is going to be the radius times cosine of your angle. So you should put an angle in there. And you get your y coordinate, r sine theta. And that's pretty much the idea. That's what we did every time. We just take the radius times the cosine theta to get x, radius times sine theta to get the y. Now if we go the other direction, we got to be careful. There's at least 4 main ways we can answer this. It's kind of strange, but you'll see why as we do a few of these. So convert the rectangular xy coordinate back to polar form. And I did make a note, show 4 possible coordinates. So there's really an infinite number of ways, but if we just went one lap around the unit circle, either the positive or negative direction, that gives us 4 definite possibilities for any xy coordinate. So I'm going to show you the process of how to get those. Let's start with 0, 5. So going up, just up 5 on the y-axis. That one, I'm starting there because that's one we should be able to get pretty easy without doing any work whatsoever. So first up, it's a radius of 5 because I'm 5 away from the center. And if I'm going to put an angle to that, it's going to be pi over 2. And here's a methodical way to do this. Now that you've got the main kind of way you're going to think about, which is just go counterclockwise, positive angular direction. Now let's go the opposite way. Same radius of 5, but if we go counterclockwise, it's negative 3 pi over 2. All right, third way to think about it what if we want to end up with a radius of -5? So I want to have a -5 radius. Let's think about the angles that can make that happen. Well, I could go 3 pi over 2. That would work. And then come back the opposite direction. And the last thing is to try going negative for both things. We want to have the radius be -5, so we're going to be down here. But instead of going the positive direction for angles, let's go the negative direction. That would put us at -pi over 2. And that's the 4 ways you approach it. The first answer, which is kind of the common sense approach, get the angle, the positive angle that would work, get the radius that would work. Second approach, get the radius that would work, but go in the negative direction, go clockwise. All right, third option, get the opposite radius, so in kind of 180 degrees or pi radians away from where you want to be. Go in the positive direction to get there one time, go in the negative direction to get there the other, the clockwise direction. And that's really those last two. All right, let's do one you got to work for a little bit more. So -3, 4. It's going to be back this way in the second quadrant, right there. I want to get I've got XY coordinates. I want to get polar coordinates. So if this is -3 this way, and this is 4 this way, then we could do some Pythagorean theorem, figure out that that's got to be 5 for your radius, so still a radius of 5. The angle here is a little trickier. So if I wanted to solve that angle right there, it's looking like a tangent. Tangent of that angle would be 4 over -3. Put the negative wherever you want to. And we'll need to take an arctangent. Now there's a catch coming, because if you remember right, when you take arctangent, you get a result between -pi over 2 and +pi over 2. You're going to get a result somewhere in here. All right, and we can probably see where this is going to happen. We're going to get an angle that's back this way. We can verify it when we do the math, but we're going to get an angle down here. You're going to have to go 180 degrees back, or pi radians back. So if I'm going this way, I'm going to add pi to my answer, and that's going to give me the actual angle. So let's watch this play out. Now, for this part, you can use your calculator. We're going to get a radian answer. It's going to be a decimal. It's not going to have pi in it. It's not going to be a nice unit circle type value. And that's pretty typical to this section. So you just got to get used to that. It's not too bad. So in your calculator, let's make sure that we are in radian mode. Now, I've set this into polar mode, but that's really not going to affect the answer on this problem. If it makes you feel better, you can change it to polar right now, but you really don't need to for this problem. We do want to be in radian mode, though. So it was second tangent, -4 over 3. And that's going to give me -0.927. So about 1 radian in the negative direction. That's about 60 degrees in the negative direction. This one's probably close to 50 degrees. So that's going to put me back around in here somewhere. Again, that's not where I want to be. My angle's the exact opposite direction. So I want to add pi to what I get. So let's kind of play out where this is going. Mathematically, this is -0.927, let's call it that. So -0.927. That puts me down here. So to get the actual angle, I need to add pi to that. So the angle I'm looking for is actually this way. And if I add pi to this result, it's going to give me about 2.214. So 2.214, that's the angle that I'm looking at right here. Let me just kind of put that in there so that we've got it, 2.214. Again, you're not getting a nice unit circle type radian angle that's got a pi and it's a nice ratio. This is just a irrational decimal, and that's going to happen quite a bit in this section. So let's get the kind of obvious angle, or obvious coordinate here. That's going to be radius of 5, 2.214 for your angle. All right, the next thing to look for, what if we go the opposite direction? All right, well, if it's 2 pi radians all the way around, this is 2.214. Subtract from 2 pi, and that will tell you the other one. So I'm going to do 2 pi minus that result. And that's going to give me 4.069. Now that's in the negative direction here. So 5 negative 4.069. So same radius. That's the two ways to get positive 5 for your radius. The other two ways, you want to get negative 5 for your radius and see what happens. And then we just look at going the normal direction. So if I wanted to go this way, to get a radius of negative 5, I need to actually end up down here. And then negative 5 will put me back in the direction I need to be in. Well, we've already got this angle down here. It's negative 0.927. So we'll try that one. And we'll put it over there where both cases are negative. For this one, I've got a negative radius, but I want to go in the positive direction. So it's the, I don't know what the word would be for this. It's not a complement or supplement, but if the whole circle is 2 pi all the way around, and you've already taken this much out, whatever's left, so 2 pi minus that amount would give you this direction right here. So 2 pi, and since that number's already negative, I'm just going to go ahead and add that to it. So plus, and we'll scroll up to the negative 0.92 there. That's going to give about 5.356. So there we go. That's the 4 ways to get this point, this negative 3, 4 coordinate. So let's come up with a way to generalize this so we've got a method that always works. So for any point that's x, y, you go some x distance, some y distance. That means r is going to be your actual distance to the point. You've got some angle theta. Well, to get r, we know that by Pythagorean theorem, r squared is going to equal x squared plus y squared. So just to get r, square root x squared plus y squared. Most of the stuff you can figure out that memorizes some kind of formula, but if you want to put a formula to it, this is how it would go. And your theta, well, let me back up a little bit. To get theta, you're really going to need to do a tangent. So let's start with tangent theta. And that's always going to be y over x. There's not really an exception to that. It's always the opposite over the adjacent. So to get theta by itself, we'll take an arc tangent. And that'll be the method. You'll just have to be really careful to make sure you're in the correct quadrant. So remember, when you take arc tangent, it gives you an answer between negative pi over 2 and positive pi over 2. So if you're in the fourth or the first quadrant, you're good to go. If your angle's in the second or third quadrant, you're going to be a little more creative. You're going to need to add pi to whatever you get, and that'll put you in the correct spot.